Hello, everyone. My name is Nick Gengler. I'm a third-year PhD candidate in SNRE, and I'm here to tell you about the research that I have been conducting instead of fieldwork in Paraguay, which got disrupted due to COVID. So instead of that, I've been conducting research that examines the differences in scale of effect between metrics of habitat configuration and composition. So scale of effect is the spatial extent at which the landscape has the greatest influence on a biological value of interest, such as species abundance at a given location. So it's well known that the landscape influences biological values of interest, but what's sometimes less well known is how far out does that influence exert. So for example, if we have a forest-dependent species, such as this rabbit here, on a landscape such as this, which is comprised of forest and non-forest, if we were to measure this rabbit's abundance in 4 locations, we could be pretty sure that the landscape around it would influence how many rabbits were at each location. What's a little bit trickier to determine is how far out does that influence extend? If logic tells us that if we extend out too far, well, then it's just not going to be relevant anymore. It's not going to have any influence on the rabbits at that particular location. At the same time, if we are too close, then we won't be getting the full story. We won't really know what the landscape is doing to influence the rabbits. And so measuring landscape variables at the correct scale is pretty critical for understanding the effect of the landscape. We don't want to be too near nor too far. And being at the incorrect scale can have a very significant effect on our ability to detect the strength of a relationship between the landscape and a biological variable of interest. So, for example, if we were to look at the strength of forest cover for determining how abundant rabbits are, we could measure the landscape at a whole bunch of different extents, and then compare them using model comparison techniques such as comparing AIC values. And so in this graph, this is just a bunch of different models using the landscape measured at different buffer radiuses. So going from 100 meters around each focal point to about 10,000 meters around each focal point, so 10 kilometers around each focal point. And then we use model comparison techniques to determine which of these scales best explain how abundant rabbits are at a particular point. And for those familiar with AIC, you'll notice that the difference between the very best score, and AIC lower is better, and the very worst score is very significant. So if we, or even not the very worst versus the very best, but even some of the slightly bad ones can have a very significant effect on our ability to detect the effect of the landscape on rabbit abundance. And so if we were to measure the landscape at the incorrect scale, say up here or all the way out here, we might come to a faulty conclusion that the amount of forest cover does not affect rabbit abundance, when in reality it does, but we just have to be measuring it at the correct scale. And so this is already pretty well understood that you should be, measuring the landscape at the correct scale. But the tricky thing is that the scale effect can vary with many factors. Now, in particular, species traits. So it's starting to become more understood that large-bodied species have a larger scale of effect. Now, that makes sense. In addition to that, we're starting to understand more that landscape contexts can influence scale effect, whether you're in tropical latitudes or temperate latitudes, whether you're focused on a forest landscape or a grassland landscape or even an oceanic landscape. Those will all influence what the scale of effect is. And finally, what's not very well understood is how does scale of effect differ between different focal metrics. So in landscape ecology, there's a whole bunch of different metrics that can describe a whole bunch of different aspects of the landscape. Now, all these different metrics can, for the most part, be divided into 2 categories: landscape composition versus landscape configuration. So landscape composition is just the amount and diversity of different land cover types. So in this example here, we have a landscape that is composed of about 40% forest 60% agriculture, and 0% water. What configuration aims to describe is how are all these pieces arranged? How do they position themselves in relation to the rest of the landscape? And this can be described in metrics such as forest patch density or interpatch distance. What is the average distance between all of our forest patches? So both of these are important for describing landscapes, and both are commonly used in studies. However, most people tend to just use one common landscape size for all of their metrics. They'll choose, say, a buffer radius of 5,000 meters around all their focal points and use that for their measurements of composition and configuration. So I'm examining to see if that's really the case, if that can be done, or if maybe there should be more care taken into choosing your scale for each metric. So to do this, I have been conducting a dataset meta-analysis. So comparing scale of effects is very tricky, and so it requires a lot of standardization. And so I found that the best way to make these comparisons was just to calculate it myself. So that required me finding a lot of data sets that would be suitable for calculating the scale of effect. So I searched through Dryad, the Knowledge Network for Biocomplexity, and Web of Science. And using search terms that focused on forest mammals in fragmented landscapes, I found a little over 2,000 data sets that came up with my search terms. After surveying these for their titles and abstracts, 178 met my initial search criteria. And of these 178 data sets, 40 were actually suitable for my study. And each data set tends to have more than just one species. And so even though I only have 40 data sets, I'm able to calculate 190 sets of scale of effects. So if I have a data set that reports on both ocelot and jaguar, well, I can use both of those species as two independent, well, somewhat independent sets of scale of effects. So I'm currently in the process of going through and calculating all these scales of effects. I haven't quite finished. There's still a small chunk left to be done, but I've done the majority of the 190. And once I have all 190, I will be able to determine if these various metrics have similar or different scales of effect. In particular, I hope to examine if metrics that describe habitat composition have a smaller scale effect than configuration. And this is particularly relevant to the debate over whether composition or configuration is more important for landscape connectivity. There's some debate surrounding that, which could in part be addressed by figuring out which one has the wider scale of effect. And since I have all these scales of effects already calculated, just as a bonus, I can use linear models to determine what factors influence the scale of effect. So many of the other factors that I've already described, such as species body size or landscape context, I can use that to examine how does scale of effect vary with those other factors. If it's very consistent, whether species of a larger body size have larger scales of effect, or do carnivores have larger scales of effects than herbivores? There's a lot that can be examined once I have this set of scales of effects already calculated. And once I have gone through all this, the importance of this for future research will be primarily to demonstrate the importance of measuring landscape variables at each metric's correct scale. So as mentioned, researchers will commonly pick one scale and use that one scale for all their different metrics. And that could be leading to some biased conclusions, where some scales are, getting measured at their optimal scale or near their optimal scale, but other metrics might not be, and that could diminish our ability to detect their influence. So they might be seeming to be less important than they really are. And additionally, my research should be able to help researchers find an a priori estimate for their scale of effect. So hopefully my research will help them get at least close enough on their first try if they don't have the time or ability to find the optimal scale themselves. At least we can hope to be somewhat in the ballpark. If you're off by a few meters, it shouldn't be that big of a influence. So my research should help provide a priori estimates for finding that correct scale. And finally, my research will help assist land managers and conservationists to decide whether to prioritize landscape composition or configuration if their aim is to promote connectivity. And this can often be a very tricky decision. So that is the research that I've been doing over the last few months instead of fieldwork in Paraguay. As mentioned, I'm still in the process of calculating the scales of effect. So I have a few more months of work to do on this before I'm fully done. But I hope to be done relatively soon. If you have any questions or are interested, feel free to contact me there at my email. And thank you very much.